Today we are going to wrap up our first unit on the essentials of geometry, on just the basic building blocks that we use all semester long. And we're going to end it with defining some angle pair relationships. When we have two angles, what they could possibly be called together. Most of this is stuff you've seen before. However, a couple of these terms might be brand new to you. So let's go ahead and jump in with some, this is really review because these first couple I know you've heard before. Complementary angles are two angles that add up to 90 degrees. And it has to be two angles. You can't have three angles that add up to 90 are not complementary. They're just three angles. So two angles that add up to 90 degrees. Here is a little picture, and oftentimes you'll see them like this. This would be angle 1, this would be angle 2. And we have our perpendicular box, and that tells us that the whole thing is 90 degrees. And so we know that those two angles have to add up to that 90 degrees. So we would say angle 1 and angle 2 are complementary. Can't write today. And we could say angle 1 is the complement of angle 2. We could also say angle 2 is the complement of angle 1. Our next vocabulary word goes along with that. It's very similar, but it's supplementary angles. And these are two angles that add up to 180 degrees. So complementary add up to 90, supplementary add up to 180. And again, it has to be only two angles. Now these two angles can be next to each other. We'll talk about what it is when they are next to each other, but they don't have to be. And so if we had this set up, we'll call these 3 and 4. We know that this whole thing is 180 degrees because that's a straight angle. That is one of the things you're allowed to assume in a picture, is that if it looks like a line, it's a line. So we would say angle 3 and angle 4 are supplementary. I'm going to run out of space. Got to squeeze that in there. That says supplementary. And we could say angle 3 is the supplement of angle 4. And angle 4 is the supplement of angle 3. And so knowing these two vocabulary words, if we know one of the angles, we can figure out the other one in the pair. So for complementary, if angle 1 is 50 degrees, well, 50 plus what gives us 90 degrees? 40. So we know angle 2 would be 40. For supplementary angles, if we knew angle 4 was 45 degrees, 45 plus what gives us 180? So we would know angle 3 is 135 degrees. All right, our next vocabulary word, this one may be brand new to you, and it's the word adjacent. Okay, adjacent angles. They're angles that are next to each other. They share a side and a vertex, but they do not overlap. So if we looked at, okay, that'll be angle 5, that'll be angle 6. So angle 5 and angle 6 are adjacent. We don't have another, we wouldn't say angle 5 is the something to angle 6 like we did with the others. But see how they share this side and they share a vertex. So it has to be set up like that. And notice they do not have any interior points in common, which means they don't overlap. So as we see examples of this, this should become more clear, but that might be a brand new concept for you. Or for example 1, we want to name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Now, just going back to the vocabulary, complementary and supplementary they don't have to be adjacent. So they can be, and that's fine, but they do not have to be. So as you are naming angles, you do not have to have adjacent angles to be complementary, like our picture showed. All right, so here we've got, let's do our complementary angles. I'm just going to write comp, and okay, 122 is already greater than 90, so we know that it can't add up to anything to get 90. So is 58 and 32, if we added those two together, would we get 90? We would. So we'll say angle RST and angle BAC. Those are complementary angles because they add up to 90 degrees. Now for supplementary, if we took these two angles and added them together, that would give us 154. That's not good enough. That's not 180. We know these two add up to 90, so they can't be supplementary. If we did 122 plus 58 though, that would give us 180 degrees. So we know these two angles are supplementary. So we'll say angle RST and angle CAD. And remember, you could name each of these backwards. So this could be TSR and DAC. That would be fine, as long as that vertex is in the middle. And then finally, adjacent angles. I'm going to abbreviate that with ADJ. We know it can't be RST because it's not next to anything. It doesn't share anything with either of the other two angles. But we can see here, they share this side. They share the vertex A. So angle CAD and angle BAC, those are adjacent angles. And adjacent angles are the ones we need to use the angle addition postulate that we learned previously. All right, so let's do some work with some of these. Given that angle 1 is the complement of angle 2, and the measure of angle 1 equals 68 degrees, find the measure of angle 2. Some of you have already typed it in your calculator and figured out the answer, but I'm going to go through it step by step. If we know they're complements, then that means the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And we are told the measure of angle 1 equals 68 degrees. So we substitute it in right here for the measure of angle 1 because we knew what that was. And so just as though we had an x there, we're solving an equation. So just pretend like this is an x. If we had 68 plus x, we'd subtract 68 from both sides. So we'd get x equals, but we'll write measure of angle 2 equals, and 90 minus 68 is 22 degrees. And because we're talking about the measure of an angle, we do put that degree mark on there. Example 3, very similar, but now we're dealing with supplements. 3 and 4 are supplements, and the measure of angle 4 is 56 degrees. So we know that angle 3, the measure of angle 3 plus the measure of angle 4 equals 180 degrees. We know that angle 4 is 56 degrees, so we can put that in. And then, like we did before, we will subtract. So the measure of angle 3 will be 124 degrees. Now, do you need to write all these steps out? Not necessarily for these simpler ones, but we will see some that are a good bit more complex. Once we start getting into algebraic expressions for our measurements, it will be helpful for you to write it all out. Some more vocabulary. A linear pair, first of all, is a pair, so that means there's two of them. They're two adjacent angles whose non-common sides form a pair of opposite rays. So if we have these two angles, we'll call them 7 and 8. You can see that this side they don't have in common. They don't share that side, and that forms a straight line. They do share this side, that's what makes them adjacent. So we would say angle 7 and angle 8 form a linear pair, or you could say are a linear pair. Both of those would be correct. And because of this, the way this is set up, we know this is 180 degrees. So we also know that a linear pair is always supplementary. So if you have a linear pair, you know that the angles will be supplementary. If you have supplementary angles, you don't necessarily know that they're a linear pair, though. And our last vocabulary term is vertical angles. These are two angles whose sides form two pair of opposite rays. That seems kind of confusing. But when we have two lines that intersect, we'll call these angles 9, 10, 11, and 12. The angles that are on opposite sides of each other, so angle 9 and angle 11, are vertical angles. And that's these two, see how they're opposite. And then 10 and 12 are also vertical angles. And sometimes I'll abbreviate this with VA or vert and then the angle symbol. So when you see those abbreviations, that's what that stands for. And we'll learn more about vertical angles here in the next couple weeks. So let's do some identifying, because that's what we're focusing on today. Identify all linear pair and vertical angles. Now when we're doing this, since we have numbers in there, we're not going to try to combine angles and say like this angle, this big angle that's made of angles 2 and 3 is a linear pair with angle 1. That gets too confusing. So for starters, we'll just say, are 1 and 2 a linear pair? And they are not, because they don't form a straight line. They don't form opposite rays. Are they vertical? No, because they're next to each other. What about 1 and 3? Well, no, because those are nothing. What about 1 and 5? Well, if you take out, pretend this ray is not there, then 1 and 5 you can see looks almost like our figure we just drew. So angles 1 and, I'm going to write it in red, angles 1 and 5 are vertical angles. And then look at 1 and 4. Are those anything? Well, those form a linear pair because you have this straight line on one side there. So we'll say angle 1 and angle 4 are, and I'll usually abbreviate this lin pair or just LP for short. Let's see if we have any other linear pairs. We checked 1 with everything. 2 and 3 aren't anything. 2 and 5 aren't anything. 2 and 4 looks like they could be vertical, but we would need this to be extended. So 2 and 4 aren't anything either. And we don't need to check 2 and 1 because we already did that. 3 and 5, those are nothing. 3 and 4, those are nothing. What about 4 and 5? Well, 4 and 5 form another linear pair. So we had 1 pair of vertical angles and we had 2 pair of linear pair. Now everyone's favorite thing to do is word problems, so let's try a couple of these. When you're doing these in geometry, it's always helpful to try to draw the picture. So 2 angles form a linear pair. So we know that it's going to look like this. A linear pair always looks like that. The measure of one angle is 5 times the measure of the other. So find the two angles. So if we call this small angle x, the other one has to be 5 times that amount. So it's going to be 5x. And because we know this is a linear pair, we know that the whole thing is 180 degrees. So we could say 5x plus x equals 180. Combine your like terms to get 6x equals 180. We'll divide both sides by 6. So x will be 30. So one of our angles is 30 degrees. But we still need the other angle. And so we could just say 5 times 30. And that would be 150 degrees. So there's our two angles, 30 degrees and 150 degrees. And to check, do those add up to 180? They do, so we know we're good to go. And our last one, the measure of an angle is twice the measure of its complement. Find the two angles. That's not what I want to do. Okay. We'll call these, we'll just go back to 1 and 2. These are angles 1 and 2. So we know that angles 1 and 2 add up to 90 degrees because we're told they're complements. One angle is twice the measure of its complement. So one angle's got to be x, the other one has to be 2x. I'm going to change how I write these just so that way it doesn't blend in with the angle numbers. So we know that angle 1 is x, angle 2 is 2x, and they add up to 90. Combine your like terms, we get 3x equals 90. Divide both sides by 3. So x is 30 degrees. So then 2 times that is going to be 60 degrees. So we've got a 30 degree and a 60 degree. Do those add up to 90? They do, so we know that we did it correctly. So that's it for our angle pair relationships. We will get in more into what we can do with these angles. So just to recap, complementary angles add up to 90. Supplementary angles add up to 180. Adjacent angles share a side and a vertex, but don't overlap. Then a linear pair is two angles that are adjacent and create a straight line pretty much. And finally, vertical angles, when two lines intersect, they're the ones that are across from each other. So make sure you do your Google form and get ready for your practice. Good luck.